This video is going to discuss chemical reactions and what signs we can look for to know whether or not a reaction has actually occurred. So we've kind of talked about chemical reactions before, but matter itself can go through two different types of changes. The first type of change is the chemical change, where a new substance is created, which is what we're going to be focusing on. But there also can be a physical change, which is something that's just going to alter the appearance, but does not actually create a new substance. A good example of this would be if you boil water, you will create steam. However, steam is still water. And it's just in a different form. It just goes from being a liquid to a gas. Or if you freeze steam, it goes from a liquid to a solid. So that would be considered a physical change. You change the way that it looks, but you haven't changed the chemical formula itself. The best way to determine if you have or have not created or have not undergone a chemical change is to think about, can you turn it back to the original substance? If you can't, then you have undergone a chemical change. Examples of physical changes, like I said before, freezing or boiling, those are examples of physical changes. Melting, an ice cube melting is physical. If you paint on a piece of paper or color or write, you have added ink to the paper. However, you have not physically changed the paper. If you tear something or break something apart, again, you haven't, even though this dish is broken, it has not turned into something other than glass. Or if you tear the paper, it's still a piece of paper, it's just in smaller pieces. Whereas the chemical change, anything that involves fire is a chemical change. Rusting is an excellent example of a chemical change. Any form of cooking is a chemical change. You can't unfry an egg. The leaves changing in winter and food going bad or rotting, those are all examples of chemical changes because you cannot put them back to their original form. Again, we've talked about this already, but in order for there to be a chemical change, the bonds between the original molecules that have started the chemical reaction have to break apart to allow them to reform into something brand new. Okay, so now that we know how and why a chemical change occurs, we need to think about what we can look for to know, is this a physical change or is this a chemical change? The first sign to look for is, believe it or not, just a change in appearance, but we need it to be more than just a tearing or a breaking. If there's a change of color, then that is a really good sign that there has been a chemical change. If the shape or texture or size of the substance changes, that is a good sign. So think about some of the labs that you did earlier, where we added iodine to the liquid and it turned the dark blue, purple color. That was a sign that there was a chemical change. Another sign to look for is the production of gas. So if you see any kind of fizzing or bubbling, or if you see smoke, that is a really good sign of a chemical change. The production of a precipitate. So in this situation, it's when you add two liquids. So liquids that you can see through that aren't cloudy. When you combine them, suddenly they do get cloudy, and there's the production of like a very fine powder. That powder we call a precipitate. And then finally, there has to be a change in energy. Either heat is gained or heat is lost. In chemistry, heat is energy. So when we talk about anything that has to do with temperature, if we increase the temperature, that means we're increasing heat, which also means we're increasing the energy. And if we decrease the temperature, we're decreasing the heat, which means we're decreasing the energy. So those are our main signs that we are going to look for. Again, when we're talking about a precipitate, you guys did this with the mixtures laboratory, the little mini lab that we did where you combined your copper sulfate and your sodium carbonate, and and after you had run them through the filter, and all of a sudden it turned from this translucent blue liquid to this teal color, and there was suddenly a powder in your test tube. That powder is the precipitate. What's really important here is that you have to have two liquids. If you have a solid, it doesn't count. So putting a solid in a liquid and having a powder be formed is not a precipitate. You have to start with two liquids, and suddenly, boom, you have a solid in your container. In order for any type of chemical reaction to occur, and we're going to learn a little bit more about this when we talk about controlling our reactions, there has to be some activation energy. Activation, just like what you would think of in English class, means to start off. There needs to be a certain amount of energy that will start the reaction. Otherwise, the compounds will not react. Every different reaction has a different requirement for what that energy is. But no matter what, there is an initial spark that needs to start that reaction. So if I wanted fire, for example, is a chemical reaction. If I wanted to start a fire, I have to first have a spark from a lighter to get that fire going. So when we lit the Bunsen burner, you could hold that lighter you could hold our flint lighter over the gas for as long as you wanted, but if you don't actually create a spark, you will never create fire. So the spark is the activation energy. What happens after the reaction has started will put the change into one of two categories. It'll either be considered endothermic or exothermic. Thinking back to other words that you have heard that have these beginnings, endo means inside and exo means out. So, like an exit is you go out. So, an endothermic reaction, it needs to have that activation energy, just like all reactions do. But after the reaction starts, it actually needs a constant source of energy in order to keep it going. Typically, what we will see is a drop in temperature if it is an endothermic reaction. If your temperature goes down, that means the reaction is taking energy in, because again, energy and temperature are the same thing. So if we see a drop in temperature, that means there has been a loss of energy. So the reaction is taking energy from the outside environment and using it to complete the reaction. Exothermic, on the other hand, after that initial energy, it actually releases energy. So it gets the initial spark from the activation, but then it starts to produce its own energy and it gives off that energy, which allows it to keep going and going and going. What we see when energy is released is that temperatures will begin to rise. So fire is an exothermic reaction because it gives off heat. Any type of reaction that's going to give off heat is going to be exothermic. Any type of reaction that decreases temperature is going to be endothermic. So some examples of endothermic, any type of cooking or baking. If you are baking bread and you get it started, your oven warmed up and you put the dough in, but then you turn off your oven, even though the dough might start to rise, once the oven cools down, it will stop cooking and you will not finish the baking process. So baking and cooking, they need a constant source of energy to keep it going. Photosynthesis is also an example of an endothermic reaction. Photosynthesis will not occur if there is not energy from the sun. So the sun has to be hitting the plant in order for energy to be absorbed and run the photosynthesis reaction. Instant cold packs are another great example of an endothermic reaction. After you pop the bubble inside and those chemicals start to mix up, the temperature of the cold pack drops. The reason it drops is because it is taking energy from the air and from wherever you place it. So if you hurt your elbow, when you place it on your arm, it's going to be absorbing the heat from your body to run that reaction, which is why it feels cold to you. Examples of exothermic reactions, any type of burning or fire is going to be exothermic. Rusting is exothermic, explosions. And then finally, anything that's going to produce heat or smoke is going to be an exothermic reaction. So again, we have 4 different things we can look for a chemical reaction. We can look for a change in appearance. We can look for production of gas, production of a precipitate, and a change in energy. And for that change in energy, it could either be an increase in temperature or a decrease in temperature. Both would count as a change in energy.